Click the link in the description to download your own copy of this video's problem. Hey guys, Dr. Brett here coming at a fantastic chemistry video, and today we're going to talk about drawing Lewis structures from molecular formulas. Now, there's another video that I did about making Lewis structures from molecular formulas. It can be found here. I'll link to it in one of these corners up here. This one now, we're going to be a little bit more complicated because now we're going to deal with multiple bonds. Okay? Not a big deal. It's actually very simple. Just there's going to be multiple bonds. We've seen single bonds. Now we're going to see double bonds and triple bonds. Not a problem. Let's start with oxygen, O2. We know oxygen has 6 valence electrons. Now, how do we know that? It's in group 6A or group 16, depending on how you want to say it. So we have 2 oxygens right there. So before we do anything else, we know that these oxygens have to bond together because there's only 2 of them. They must be bonded together. So just bond them, right? Not a problem. Now, when we take 1 electron from the red oxygen, 1 from the blue oxygen, we make a bond. So we made this bond right here by taking this electron and this electron, putting them together, and they make a single bond. But now, 2, 4, 6, 7, 2, 4, 6, 7. The octet rule is not satisfied here. So we have to make another bond. We have to make another bond between oxygens. Now, luckily for us, there's a single electron here and a single electron there. So these 2 electrons will also come together to make a bond. And that bond is called a double bond. 2, 4, 6, 8. Remember, every bond counts for 2. There's 2 lines between each atom, so each line counts for 2. So that's 4 total electrons in a double bond. 2, 4, 6, 8. 2, 4, 6, 8. So in this Lewis structure, every oxygen has 8 electrons. That satisfies the octet rule. That means this is the structure of oxygen, O2. Moving on. Nitrogen, N2. Well, nitrogen's in group 15, or 5A. So we know nitrogen has 5 valence electrons. Okay, so let's say the blue nitrogen and the magenta nitrogen are coming up together. Now we can take these 2 electrons and we can make a single bond. Not a problem. So let's just do that. We're going to make a single bond between nitrogen and nitrogen. We'll make it green just to keep things colorful. We also know that we can make a bond between this we can make a bond between this lone pair and that. They're not lone pairs. We also know that we can make a bond between this electron and that electron. They can come together as well. So let's just get rid of that one. Put another bond between them. Now let's just count electrons just for fun. 2, 4, 6, 7. 2, 4, 6, 7. So we're not done. Nitrogen does not have an octet. So that means that this electron and that electron will meet up to make another bond. And that will make a triple bond between the 2. Okay, so now remember, every bond counts for 2. A triple bond has 3 bonds. 3 times 2 is 6. So a triple bond counts for 6 electrons. So 2, 4, 6, 8. This nitrogen has a filled octet. 2, 4, 6, 8. This nitrogen has a filled octet. So that means the nitrogen satisfies the octet rule. Every nitrogen's got the octet. Every nitrogen should be content with the bonds it has now. All right, let's go to a little bit tougher question. This one over here. Carbon has 4 valence electrons. Oxygen has 6. And there's a couple of hydrogens. This one is not a very hard question. It's just that students get a little weird about it. They start trying to do weird things like drawing multiple bonds to hydrogen. Like, don't do that. Don't. Just for me, And for all the other organic faculty members in this country and in this whole planet, stop doing this, please. It's never right. No matter who you talk to, this is always wrong. Never draw more than one bond to hydrogen. So just don't do it. So let's start this question off. Let's make a bond between carbon and oxygen. So I took an electron from here and an electron from here, and I made a single bond right there. 2, 4, 6, 7 electrons on oxygen. 2, 3, 4, 5 electrons on carbon. Now, if you wanted to, you could throw the hydrogens in there. Why not, right? Let's throw the hydrogens in. Hydrogen here and a hydrogen there. So that should have satisfied it. Everything's done now, right? Let's check. It should be perfect now. 2, 4, 6, 7. Carbon doesn't have an octet yet. Okay. 2, 4, 6, 7. Oxygen does not have an octet. But luckily, there's an electron here and an electron here. Each oxygen and the carbon have a single electron. That means we can make a bond between them. The oxygen has a single electron. The carbon has a single electron. They can bond together to form a double bond. 2, 4, 6, 8. 2, 4, 6, 8. So carbon has an octet, oxygen has an octet, and the hydrogens each have the duet. They all have filled valence shells. Every molecule, every atom is content with the bonds they have now. And that's how you draw the Lewis structure that fits this formula. All right. Now, guys, if you like this video, please go ahead and slap that like button. Leave me a comment below. Let me know what I can do for you to help you in your organic chemistry endeavors. Let me be your tutor, if you will, and I can try to answer your questions if you leave them in the comments. And if you could, please subscribe to my YouTube channel. It really does help out creators on YouTube when you subscribe to our channels. It lets YouTube know we're doing a good job. It helps with the algorithm. It also keeps me personally encouraged to keep making more and more content for you guys to help you through your organic chemistry career. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.